in a P plant, right? 1, 2, 3, 4, 5, 6, 7. Okay. So what he did is this character is equal to this character in this plant also. This character is equal to this character. This character is equal. All are equal except one. Okay. So this one was different. Here it was tall and here it was dwarf. Okay. This is monohybrid, where all the characters are similar except one character. That is called as monohybrid. Okay. So what he did, first parent of this was tall and dwarf. Okay. So this we represent by TT. This we represent by T and T. Right? So we need gametes here. Always gametes will get only half set of chromosomes. Right? Gametes are in females, it's what is gamete in female. Ovary. So I write gametes in circles. Okay, to differentiate. So when crossing over will happen, this is crossing, okay? Crossing over. When crossing over takes place, this T and T will be formed. This is not a gamete. So T and T, right? So this is F1 generation, which is also F1 is represented, F plus F is again represented by female. Something female. Okay. Check with the spelling. And then what he did is he did selfing between this. Selfing of TT and TT. IA. Okay. So he did selfing between this. This and this. So that is nothing but you'll get this one. No. TT and TT. Capital T into small, big T into small, big T into small. Right. We have two types where we can cross. Two methods we can use. Methods of crossing. One is Desi method. And the other one is Punnett square. Okay. So Desi method is where we use these lines, right? phenotype.
Here it is ET.
How many types of genotypes are there and how many types of phenotypes are there in this square HY? And this is our F2 generation, that is nothing but PDL2 generation.
2 and 2.
Mm-hmm.
2 and 2.
How many types of genotypes are there?
2.
Genotypes are two. Okay. How many phenotypes? See, genotypes, I told you that genotype is something where we represent it like this with letters, right? And phenotype is something where we can look at the plant and tell the physiology.
Yeah, but
Yeah, look at the plant. So 1, 2, 3. 3 are gone. This is one type. And another one is not. So there are 2 phenotypes.
3 is 4.
No, I'm just asking types.
So 3.
Tall commander 1 only.
Oh,
Right? So type 1 is tall. And the other type which I found is dwarf. Right? So phenotypes are 2. Okay. And genotypes are 1, 2, and 3. Because see, one is fully dominant and the other one is this homozygous. This is heterozygous dominant and this is heterozygous recessive. Okay. So we have 3 phenotypes over here. 1, 2, and 3. Right. So when we write the ratio, that is not very important. Just remember that there are 2 types of representation. Okay. And just remember this one, Punnett square.
what is it? Square represent?
The square.
Yeah, what is it represent?
It gives the ratio of the genotypes. It is a sentence of NCERT, okay? And this is very important. And Punnett square, this is a PYQ. Which square is represented, which square is used to represent offspring? Okay. This one was given by Reginald C. Punnett. Okay. This is the name. He was the scientist who gave Punnett square. Okay. When you write phenotypic ratio, and genotypic ratio, genotype types are 3, right? So tall is to the other one. Just write it like T is to TT is to small t. Okay? So TT, how many dominant homozygous?
3.
Dominant homozygous.
1.
Which is what?
BT and BT.
So this is one, right? And how many heterozygous dominant?
2.
And how many homozygous? You must be familiar with this term, okay? This is homozygous, right? So this is heterozygous. This is homozygous. Yeah. So homozygous recessive. This is homozygous recessive. This is homozygous dominant. This is homozygous. Sorry, heterozygous dominant. Okay?
These are the 4 heterozygous recessive.
You just tell dominant. Heterozygous dominant. Okay? And phenotypic ratio is tall is to dwarf. Because after all, T and T doesn't make a difference with T and T in appearance, right? So this is 3, tall is 3, is to 1. This is the ratio. These ratios are important. Take it out. So I have a question. Take it out. one of its parents. True or false? And the next one is F1 generation is neurotypically similar to one of its parents. True or false? Just one question. Can I answer?
First one is
Why true?
because it's T. So F1 is also T.
Our parents is TE and TT. These were our parents, right? So these are parents. And our F1 generation was capital T small t, which is tall. And here, this is tall. Right? So the question is F1 generation is similar to one of its parents. It is similar to, it is tall. And this is also tall. So it is similar to one of its parents, right? This is true. Remember the second one.
F1.
Mm-hmm.
Similar. No, it's not similar because one is dog. Genotype is similar.
Genotype is similar.
Yeah.
It is false. See, F1 generation, what we got F1 generation is T and T, right? But then the parents were TT and small t, small t. I'm asking genotypically. Okay? Genotypically. Yeah, this is tall and this is dwarf. So if my F1 generation was either TT or if it was small t, then it was similar. But it is heterozygous. Right? So this is heterozygous. Take it down. I want you to take it down. I need to do extra time now. I'll just tell you something now. This is homozygous. So Mendelian inheritance or crossing, Mendelian crossing, Mendelian cross or experiment. Big down fast shows that there is no blending. Experiment. It is a qualitative inheritance. those monohybrid are also called as
one gene inheritance.
so this is two gene inheritance, okay? Take it down. Done. In this, his parents were with the characters round and seed shape and seed color. Seed and seed color. Okay. So in seed color we have two, yellow and green. I'll write it this side because I don't know it once. Yellow, so we write with capital Y and green with small y. And seed shape we have to round, capital R and bring small. These were his parents. Okay. So this can be represented as R, and R. This is capital Y, small y. So his parents were ultimately capital R, small r, capital Y, small y, that is parents. Okay. So when I take gametes of these, what would be the gametes? This.
Capital R, small r.
This.
Capital R, small r.
Okay. So he did crossing between this and this. That is what we did in monohybrid also, no? Crossing. So what will be the F1 generation here?
Capital R.
Capital R, small r, capital Y, small y.
Oh, okay. They were merged.
You have to write one character one side. Another character one side. Okay. So this one was a F1 generation. And this one is heterozygous. Yes or no? And this is round yellow. Right. So crossing between this RRYY into RRYY. Okay. These are the F1 generation. F2 generation का parents. Generation parents. Okay. So gametes will be RY one, okay, and RY another one, RY another one, and RY another one. Okay. These are the gametes of these parents. So here also it will be same. Right. So when I take Punnett square for this, right? So this side female, this side male, and the gametes are RY, 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 RY. Here also it will be same. Okay. So R and R, Y and Y, R and R, this R and this R, this Y and this Y. I want you to see. Capital R, small r, capital Y, small r. Capital R, small capital Y, small y. Okay. Capital R, capital Y, small y. Capital R, small y, small y. Capital
ये
R.
गाना नहीं गाना है कैपिटल स्मॉल आर अभी तुम बोलो
पता है I'll do next. This small capital.
मेरे काम निकाल दिया हाँ एक लड़का वो खाता गैस पर बाल खाता है पता नहीं
Done?
फिर खाएगा या
These are the results.
उसका नाम क्या है
So this one is round yellow. This one is also round yellow. That's what I would grade. Take it out. So here, how many types of phenotypes are there? See, one is round yellow. Round yellow is round green. Then wrinkle yellow. I'm asking how many phenotypes out there appear these. Okay. And then wrinkle green. So how many are there? So 4. Okay. Round yellow are 9 count. 1, 2, 3, 4. That's 5, 6. Wait. 1, 2, 3, 4. 5, 6. This is 6, okay. 6, 7, 8, 9. 9 round yellow, okay. So this is 9. And how many round green are there? Round green 1, 2, 3. Right? So 3 round green. Okay. Wrinkle yellow 1, 2, rest of them are round yellow. Okay. Understood? So when we write phenotype, it is round yellow is to round green is to wrinkle green is to wrinkle is to wrinkle green. Okay. So round yellow is 9, is to 3, is to 3, is to 1. So the ratio will be 9 is to 3 is to 3 is to 1. Right? So phenotypic ratio is equal to 9 is to 3 is to 3 is to 1. Okay. Understood? Take it. Just take 5 minutes, then you can go home. Look at this. How many parental combinations are there in this one? Parental combinations is nothing but the first parents which I did. This is round. Wait. Yellow, green. Actually, these are not my parents. Take this one. There is one. We have a hair round yellow, right? Round yellow and brinker green. These are my parents. Just don't get confused with this. Don't get confused with this. Round yellow is here. So not writing it. Okay. I want parental combinations. You have written this? Okay. So parental combinations. Here if we take, it's round yellow and wrinkle green. Right? So how many round yellow did I get in the phenotype? Round yellow is 9 or 4. 9 plus wrinkle green is only 1. See, wrinkle green is only 1. Right? So plus 1. How many offsprings did I get?
Total 16.
So it's 16 is equal to 10 by 16 is my parental combinations. Okay. And non-parental combinations.
Why did you take 3?
That is not parent. No, see, round and green. Where is round and green? Round is dominant and green is recessive.
Okay, we need dominant and dominant.
Okay. You understood? Those will come